Alright, so here's the function, x squared plus 2x minus 3 over x squared minus 6x plus 9. I'm going to show the steps I took to graph it, or sketch it. The first thing I did was I noticed the numerator and denominator were factorable, so I factored them, just to make future steps easier. After that, I found the x-intercepts, so I made it so that y is equal to 0, and then I subbed in y is equal to 0 for y, and then I cross multiplied, and after cross multiplication I got this equation. Then I solved for x, and I got x is equal to 1 or x is equal to negative 3. So therefore the x-intercepts are at 1, 0 and negative 3, 0. After that I solved for the y-intercept, so I subbed x equals 0 into the function, and then I solved for y. So I got y is equal to negative 3 over 9, which I simplified into y is equal to negative 1 over 3. So the y-intercept is at 0, negative 1 over 3. After that, I found the vertical asymptotes. So I made the denominator equal to 0, because when the denominator is equal to 0, the function is undefined as it's divided by 0. And that's where the vertical asymptote is. So I solved for that, and I got x is equal to 3. So the vertical asymptote would be at x equals 3. Then I analyzed the behavior of the function near the vertical asymptotes, so that for when x is approaching 3 from the left side, I chose a number that was just to the left of the vertical asymptote, which is 3. I chose 2.99, and I subbed that into the function. Using my calculator, I calculated it, and I got a positive number. So the function would be going in the positive y direction when approaching from the left. And then I did the same thing for the right side, and I put a number that was just to the right of the asymptote, which is 3, and I put 3.01, and I once again got a positive number, so the function would be approaching the positive y direction when approaching from the right as well. After that, I found the horizontal asymptote. I noticed that the degree of the numerator and the degree of the denominator were the same, and using the shortcut to find the horizontal asymptote, which states that if the degree of the numerator and degree of the denominator are the same, then the horizontal asymptote is the coefficient of the highest degree numerator, highest degree number in the numerator divided by the coefficient of the highest degree number in the denominator, and both the coefficients of the highest degree in both is 1, so I did y is equal to 1 over 1. So the horizontal asymptote would be at y is equal to 1. Finally, I found if there were any crossings of the horizontal asymptote. So I subbed the horizontal asymptote for y into the function, which is 1. So I subbed y is equal to 1 into the function. And then I cross multiplied. And then I expanded and then simplified it, crossed out the x squared. And I got this equation, which I then solved for x. And I got x is equal to 12 over 8, which I simplified to x is equal to 3 over 2. Which I then converted to a decimal, since it was just x is equal to 1.5, which is a pretty clean number. So that means there would be one crossing point of the horizontal asymptote at 1.5. Okay, so then I sketched the graph, and here it is. Yeah. Let's see. I have all the points, I think. Yeah. The asymptote.